Hi everyone. In this video, we're going to look at the recent rack project that I've created. I've created this rack system on top of Paul Graham's essays. Paul Graham is the co-founder of Y Combinator and he has written a lot of good essays over the years. I've tried to create a rack system on top of this essays collection so that it can query any information that you want from this data set. A quick overview of things under the hood. So it starts with the ingestion pipeline. You first have to chunk these files and create corresponding embeddings for the same. I use the nomic embedding for this project. And then you index these embeddings and also save it in the memory so that it's easy for retrieval. When the user actually comes and requests for the query, the agent orchestration loop smartly leverages the memory as well as it uses the LLM agents to leverage the search knowledge functions, leveraging the vector similarity search to kind of get back the relevant files to the LLM so that the LLM can actually process and give the final answer to the users. Just the high level overview of the different pieces. I'll not go into the details of this GitHub repo, but I'll try to explain it with the code as well directly. A quick overview of this particular GitHub project. So it also has some sample queries from Paul Graham's track samples. So for each, you will see about 5, 6 of them. It starts with a query. What is the purpose of testing it? How it's different from lexical? How it uses semantic search? And then the results for each of them. I'll not go into the details because I'm going to explain it with the code. And each of these queries also has a failure case where if vector index is not available, how would the case be? And you will see a lot of queries on the same. The second half of this README file of this project is more on the foundations of agentic queries and not really related to this project. So if you're going through this README, feel free to skip this if you're not interested on the same. But these are some of the foundational queries that we have for multi-agent as well as foundations of rack systems. With that, let's jump into the code to showcase you how the flow works. So let me walk you through the different queries that I've worked on, starting with the foundational multi-agent work, and then starting with the foundational rack systems, and then the custom rack system that I built. So we'll start off with the foundational multi-agent workflows. Like we saw last time, it's going to be more or less the same. This query is about fetching the information from Wikipedia and then responding with a summary of the key details available in Wikipedia. What's different from last time is that currently the user query is also converted to embedding, and then the response is also saved in memory as an embedded content so that it can be retrieved later on. So these queries, the initial foundational queries, will be more about from a regression point of view if things are working as last time. The next one is about Tokyo activities and weather. Again, similar goals being assigned. Goals are knocked off one after the other. And then finally, once all the goals are knocked off, you get a final summary, what you need to do. These two queries are about setting reminders for mom's birthday as the first query and setting a reminder. Again, multiple goals, save the date, set a reminder again. Once all the goals are met, it gives a confirmation that these are the files where it is written. And once I can also query the date again to ensure that if it actually remembered. As I mentioned now, the query actually happens through embedding to embedding match because the user query is also embedded and the memory is also embedded. Now you also have another async IO related inquiry searching 3 results from the web. Again, for every iteration, the goal gets completed one by one. The first search results processed, second is processed, third is processed, And then finally, the final synthesis is processed, and then the information is given to the user. A typical multi-agent workflow, all are intact even after moving to the embedding and rack system. With that, let me now jump into the foundation of the rack systems. Here we have a set of papers related to hold on. Yeah. So related to attention, chain of thought, LoRa, and few of these. And I've also created a polished version of this document because we noticed that the quality was not that good because it had a lot of, so this is the cleaned up version and this is the default version. You see a lot of HTML links, formattings, navigation links are there that makes it uh, the rack system having a lot of noise, which reduced the quality of retrievals. So this is the first file where we are asking the system to index a particular file and then retrieve information from the same. So you see out of the goals, the first one is about indexing it, and the next one is about retrieving the same. And the third one is about summarizing the same. You can see one by one. First is the index document, which is the indexing part, the search knowledge is the retrieval part, and finally it's the once both are done, it summarizes the content and gives out the information here. The next one is about running indexing on all the files that was there in the folder, papers folder. So you can see out of all the files, these are all made searchable by indexing one by one. It's knocked off, embedding, indexed, embedding, indexed, embedding, indexed. And then finally you have 5 chunks for all the 5 files because we have cleared up a lot of noise. It's only 5 files. Earlier it was more than 5 files, about 12 to 15 chunks were there. Chunking is just separating bigger content into smaller chunks so that you can index it with better quality. And once it's all chunked, I can now retrieve information like, hey, give me chain of thought related reasoning, and it'll query across the files. Now currently it's in memory, so you don't see the search knowledge function. It's from the memory, it's searching and giving you the relevant information, search and synthesis, and then giving you the final answer across the different files that is there. One second. Yeah. Uh, this is just a sample of with the noise. So chain of thought reasoning, the same query with before the cleanup I did, it was not actually giving a response at all because it was saying that there's not much provided hits. There is no information regarding chain of thought reasoning. So I had to do the cleanup to make the quality improve. The last one is a semantic search, sorry, uh, where we are not using the word that is mentioned in the phrases. We are using the word called credit assignment, which is exactly not available inside the paper, to see if it's able to find the related contents. Again, a simple query and synthesis two-step process. And you can see that it has found the chain of thought related content across different files, not just the chain of thought file, but across the React and DPO files as well. And the next query is about cross file referencing. So comparing React paper and chain of thought paper to find uh, uh, the the different reasons for the same. So you can see that the first thing is queried, the second paper is queried, and then the third goal is comparing how the intermediate reasoning is done across these two papers. So once both are fetched, final synthesis happens, and then the response is given to the user. Now let's jump into the custom rack system that I created. Uh, just like the papers, I fetched all the uh, Polygram's essays and then cleaned up, formatted into the structure that I prefer. These are all separate JSON files for every essays, which has title, link, date, and the content. And I used a bulk index file to actually index it one shot because it was 50 files. I didn't want to do it as part of the query. And then once it is indexed, I could just directly go and ask questions based on the essays, and I tried to stress test with a lot of semantic queries. So these are the different semantic queries I tried. So my first query was about how shy geeks show their teeth. It's about how fierce nerds actually are aggressive. I didn't want to use the exact words, but I used similar words and try to see if it's actually returning this content. And you can see from the response that the structure is going to be the same. I'm not going to go through each of them. It'll do a query and it'll do a synthesis for pretty much all the files. And you can see that it has actually done search knowledge and found the file uh, essay fierce nerds, and it's actually returning the summary of the same. And the similar failure case that if the index is not available, I manually turned off the index. So if the same index is not available, you can see the same run keeps on going, and then finally it says the phrase shy geeks showing teeth does not appear in any of the memory chunks, or we are not able to provide any information on the same. So that's to showcase the positive case and the negative case. Starting with the second query on semantic recall, again, stress testing the semantic search. We're using a query related to charm and authority. We're asking, hey, why is magnetic charm usually an illusion created by authority? The actual paper is about charisma and power. So we are trying to use semantic similar names to query the similar content. You can see that in the results here. Again, structure is going to be remaining the same. Search knowledge happens and you can actually get the related content, which is charisma power, published January 2017, and this is later synthesized to give you the final response. This is the negative failure case for the same query. You can see that it keeps on going for multiple iterations. I think it went to about 13, 14 iterations, and I had to kill the same because it was just using a lot of API calls, and it was trying to navigate through the directory, read the files, because it was not having that semantic index that's available. The next query is related to again a semantic recall related testing. So you can see this is related to the essay called haters, but instead of using the word haters, we used semantically similar words called obsessive dislike. Why do some individuals develop obsessive dislike towards famous people? And asking it to give a reference of the essay and the date. And once we go, this is query K. So query K is pass logs. So you can see here similar structure. Query is successful. It finds the correct essay called haters, January 2020, and the synthesis is also available. Why do they usually do that? And the failure case for the same is here. You can see it is actually picked up some other article, and it's actually giving completely different information about dynamics, ideology, social media, all of that, not related to the actual haters article that I actually inquired about. Again, to showcase the side-by-side difference of what happens if the semantic index is there versus not there. With that, let's jump into the next query, query L. Um, Here it's about synthesis of a long document. Let me directly go into the scenario. So from all these essays indexed, summarize the top 3 tips related to writing. Again, it'll go and understand related to writing. In this case, this was a very big document, how to write usefully, about 9 chunks it has. It tried to leverage it from the memory, and it tried to write it the synthesize the final response for the same, and then give us the final summary. And you can see it's pretty detailed summary of 3 points from this one article. This is not related to semantic, it is more about synthesizing from a bigger file. And then failure case is also there, and the failure case is interesting. Even though it's a very obvious write related command, you can see the kind of response it gets. childlike confidence, prioritize curiosity, doing good work over hacking. These are not related to writing. These are not the responses for writing related tips. This is a negative case to showcase that without these semantic indexing, the quality of the system will be very low. The next one is multi-essay synthesis. So here I'm asking, out of all the essays index, choose any two essays to talk about startup survival. Even most of these articles are about startup. I asked to fetch at least two of them to summarize for me. So again, similar format, it'll fetch both the files and provide the synthesis. And you can see the final response here. These are the two essays from which it has been chosen. And then these are the summary of each of these essays. So that's a quick explanation of all these log files and how things work. I think I already touched upon the different agents that we have here. The only difference is the agent bulk index that I did for a script I wrote for all the 50 files to be indexed and embedded. Otherwise, all the regular multi-agent work um, stands as status quo. Separate roles for decision, perception, memory, action, all of that is status quo. That's a quick video on my RAG journey so far. This is still starting, but yeah, wanted to do a quick video on the same and then share it across. Thanks everyone for watching.